Okay, so I should probably start from the top. Skyhook is, we essentially do Wi-Fi positioning, but it's kind of a better way to describe it. Software-based, wide area location platform that leverages Wi-Fi instead of satellites to do positioning. So think of it very analogous to GPS, where GPS uses satellites for reference, we use wireless access points. Might ask, how do we know where all the wireless access points are? We have about 400 drivers around the world that canvass up and down every street, much like Nath or Tally Atlas, if you know the mapping space. Those drivers are contract drivers for us. We've started, really, founded in 03, raised money in 05, and that was when kind of the mission began of driving the world, picking up all these signals around you to use for reference for positioning. So in the end of 06, we finished finally driving the US, and we look at kind of coverage in terms of population density. So in the US, it's very easy. You have census tracts, you can figure out where all the people are, what's the least amount of driving you need to do to get to the most population, and there's obviously some kind of loss and return at some point. So we focused on about 70% population density and finished that in 06.
How often do you have to redrive? I mean, I've been through 3 routes.
Yeah. So it's probably the first question everyone wants to know, right? It's the answer is it depends on each area. So typically we say about 18 to 24 months for any kind of given area. That's kind of the average. Places like Boston, where we have about 300,000 students, we may have to do maybe 9 to 12 months in certain pockets. The beauty of the system, though, is we actually get analytics back, and every single time someone makes a lookup, whether it's the iPhone or laptop, we get that scan data sent back to our server. Say we see 12 of them in the scan, which is about average for a scan, and we recognize 9 of them. If in the next scan we start recognizing fewer and fewer of them, we get that information back to determine that there's some decay rate increasing in that area. We can go drive a pocket of it without having to go say we're going to go redrive Boston totally. So yeah, it's kind of a self-healing way also. So if we have enough information in that scan to know where that user is still, we can reposition those new access points or know the ones moved from a new location that we saw somewhere else. So that now that we're at 45 million APs, and when we announced with Apple in January, we announced I think 23 million or 25 million access points at that time. So we've almost doubled the database in a few months, just because of the devices that are out there in the world going around. We've also increased our drivers probably about twice as much.
So as a result of driving, are you actually surveying each access point, or are you getting signatures?
So yeah, we care more about how the signal propagates and less about where the actual access point is. Because obviously you can assume that an access point might be in a single location and doesn't broadcast in a perfect circle around that area. It'll propagate down streets much better than it will through buildings and through hard objects. So we have a driver every 1/10 of a second log their location and the scan information, and that information then gets sent back to the system and processed to determine where we think the AP is, but more importantly how that signal actually propagates in different areas. Unfortunately I don't have a signal or a picture of the propagation stuff, but we have that somewhere. I can pull it up later if we still have questions. But the beauty of that is it gives us more information about what the actual signal is and where a user is relative to this overlay of a bunch of different signals. Like I said, there's probably about 12 signals in an average scan, 10 to 12 signals. Obviously, if you get out into kind of rural and suburban areas, it could be 0, 1, 2. There's a few places in San Francisco where we've seen up to 45. And it's interesting to note, too, that a wireless chipset will see a lot more wireless signals than you'll ever see in kind of your Windows Wi-Fi manager or Mac Wi-Fi manager. The operating system filters out access points that it thinks the signal's so weak that it won't be able to connect to. So the actual chipset information is something we can use to still do positioning, even if you could never pass data over it. One of the other kind of common questions, too, is does it matter if the APs are locked down or secured, if they're broadcasting SSID or not? And for us, as part of the FCC code, is that it broadcasts a MAC address and we get a perceived signal strength. And that's all we care about. So it could be Muni Wi-Fi, it could be your home access point, it could be an office access point, it could be SSID broadcasting off. As long as the thing is actually plugged in and broadcasting a signal, we can pick it up and use it. We don't need to connect to them to pass data over it. Depending on the mode that the actual device is using, we just need to be able to get some data backhaul. So for the iPhone, it could have wireless on, but not actually be connected to an access point because it'll send data over the Edge network, or hopefully 3G network soon. So to give you kind of an idea of what this looks like in terms of density, this is what Manhattan looks like. Each of these red dots represents where an access point is. Now there's open areas sometimes where you'll see that we don't have access points. That doesn't mean that we can't do positioning there. That just means that no access points are centered in those locations. So parks and stuff like that, like in San Francisco, we can still do positioning in Golden Gate Park because we're getting signals from both sides, but there's not very many APs in the actual park itself.